get going. This is a brief overview of today. We're going to take roughly like 10 minutes on the why temporal. I assume if you're here, you're already interested in it. So I'm going to go over really fast over that one. And then we'll try to spend the bulk of our time in code. The primary goal is to get you through the core APIs, to give you a survey of everything that you can do with temporal. And please feel free to ask questions along the way as to like, oh, but like, I read this in the docs, but it wasn't clear. And then we'll try to end off with a Fullstack Next.js app just to show you how it integrates into your existing apps. Yeah, all right, we'll kick that off. Okay, so why temporal? There's a bunch of various pitches from different people. So I want to come at this from the problem angle. And my assertion is that in any company, the most mission critical workloads are long running and tied together multiple services. What is long running? It's an interesting question. I always think about like, what is the core loop of Uber? The core loop of Uber is, pickup, the whole process from end to end of delivering someone from place to place. And it's, search, and it's pickup, and it's drop off, and it's tipping, and it's rating, and all the messiness that can happen in between. For YouTube, it's actually video processing. And if you go on to some of the YouTube engineering blogs and videos, they actually explain how they do some of the fan out and merge back in of their data, as well as even Amazon, where our CEO, first honed his distributed systems capabilities. There's a lot of sort of long-running work as well, even in something as simple as a one-click buy button. But you can also think about like even a file transfer can be long-running, because once you get into one file, it's fine, but then once you get into a million files, it's not so fine, and you need to make sure that everything's transactional. So there's a lot of use cases that are pretty interesting and long running once you get into it, and where reliability is a concern, because they are the core value proposition of your company. So yeah, I can give you a lot more examples, but you can also just check out our YouTube, where we have people presenting about how they use us, and we have case studies from all these people down below as well. All right, I'm not here to give you that sales pitch. The things I want to focus on, which is going to reflect on for the rest of the workshop, three basic requirements that you want out of your system. I don't actually care about the solution, like they just happen to drive you towards something like temporal. So because your long-running mission-critical work relies on unreliable networks and systems, you want to standardize timeouts and retries, and you want to give infrastructure to your team so that it's easy to have production quality timeouts and retries infrastructure, right? Like that should not be a part of the job of every single team that you run. They should have a common interface, and it should be declarative and all that good stuff. Because this work is so critical, you must never drop any work in the sense of you can't have sort of race conditions where we thought one system had something and then it just disappeared because it wasn't transactional. And you must log all progress in the sense that if you can log all progress, you can actually debug it and check if anything goes wrong or if there's any compliance issues. And then finally, because this work is so complex, you actually want to use code, use general purpose programming languages instead of domain-specific like JSON or YAML formats to model your workflows. And you want to be able to reuse, test, version, and migrate. Like basically, workflows are software, and you should use established software engineering practices and tools because we've spent the last 50 years inventing them. And some of the solutions may not have that approach. And so if you agree with these kind of three requirements, then you will converge on something like temporal is the solution, is the rough assertion. And I can sort of prove that to you as we go along. Bit of history. Max, our CEO, started at Amazon 15, 20 years ago and was tech lead for AWS SQS. And the other logo is AWS Simple Workflow, which is mostly an internal service these days. But I think some people still use it. Our CTO, Samar, actually worked on Azure Durable Task Framework, which turned to Azure Durable Functions. And they met up at Uber, where they worked on Shirami, which is like a messaging system, as well as Cadence, which was the Uber's iteration of Temporal. It was open source and very successful for 4 years, and then they started Temporal 2 years ago. So that's the brief history, and really, like, I think honestly, to me, there was no better endorsement than Michio Hashimoto, where they basically said, if it were not for Temporal existing, they would have to spend a significant amount of time rebuilding it anyway. And I think it's very true in a lot of larger tech organizations, that you end up having some kind of workflow platform, and it's kind of ad hocly built sort of ad hoc. And we can talk about the existing solutions and competing solutions as well. What is Temporal? I like presentations that have a clear what is. So we just covered why Temporal. Now we're just going to cover what is. So the main things to know is we're open source. We're for microservice orchestration. We're for writing durable workflows as code. And these are sort of the primary solutions to those opinions and requirements that we laid out earlier. Feel free to just pause me at any point and ask me, because I'm going fairly quickly through this, assuming that you broadly know the high level. So there are 3 components that we offer to developers, like kind of 3 products even. I think is an interesting way to frame it. So we have the open source Temporal server. Then we have developer tools that you can use to introspect on the server. And then we have the SDKs, which you can embed in your clients as well as run workers with. That's essentially the 3 main pieces that you have to kind of deal with when you're learning Temporal. It's kind of a full-fledged system. Most of the time, if you're a developer, you're working inside of the SDKs. And then if you're like a platform engineer, you're sort of self-hosting that server. And then if you're developer tools, you're also using dev tools to audit and monitor and debug. Okay. Let's keep going. So here are the 3 opinions that we have, in the sense that we need to sell you on that orchestration is better than choreography in some cases, and we'll establish the clear need for some of those cases, that you want event sourcing, I'll tell you about the value propositions that we have there, as well as workflows as code, which I'll also cover in a brief bit. Primarily, like, a lot of systems are kind of held together with duct tape, because they're piecing together a lot of like queuing systems, a lot of and like sort of impromptu state machines between the multiple different services. And basically, I feel like it's what I like to say is kind of like development by incident. Like you have a production incident, and then you're like, oh, okay, we didn't cover this, or we need this to scale, or so on and so forth. Like and then you sort of tack on individual pieces of infrastructure. And I think this is fine up to a certain point. Basically, you start to develop, every system starts to develop defenses against the other system for reliability, that you start to need to develop retries and timeouts. If every system maintainer is, and when we say system, I kind of call it like service or microservice or serverless function. I kind of don't really care. But if there's any reliance on other systems or other microservices, then that's an issue for us, because they're kind of spending their time writing their sort of retries and timeout layers, which requires not just duplicated code for every system, they're actually also duplicating infrastructure. And the argument is that it can be much more efficient if you centralize it in a single orchestrator. So for more on choreography versus orchestration, I always tend to refer to this article by Yan Cui, who actually explained like why in some situations you might want orchestration, basically within a bounded context, and then why in some, why you might want choreography, and then why you might want orchestration in different contexts. Okay, and obviously, I think the thing that's convincing for me is a big O argument. Like if every service needs to talk to another service, and they're adding their own reliability infrastructure between each of the services, then you need to sort of cut that down from sort of O of n squared to O of n by having everyone talk to a single orchestration service. And you can kind of see this within Netflix as well, with their central sort of island of orchestration. The problem is that you've kind of turned your distributed system into a distributed monolith when you kind of do that, because you've introduced a central dependency, which being that orchestrator. So that dependency just must never go down. Or it must never, more accurately, it must never lose data. And that's why we talk about event sourcing, because That's kind of the most scalable form of doing this, in a sense that if you experience any outages, we can actually just kind of bring the system back up and replay all the events up to the current date. And events that are not logged are not regarded as having happened at all. Okay, and then I think the problem with event sourcing, I think a lot of people hear about event sourcing and they're pretty sold on it until the point that they start to implement it and they find it to be a very complex beast. Here's some list of complaints about event sourcing there's on Hacker News. So there's a lot of interest in it, and I think basically the conclusions are that if you try to event sourcing, you try to implement event sourcing, you end up implementing two systems side by side. And I think that's interesting also because as a value proposition of Temporal, that we sort of abstract away event sourcing for you. We do limited event sourcing in a sense that we don't turn every single part of your system into an event source system. We just turn your application state into an event source. And then we sort of abstract that away for you via our APIs. So we'll kind of cover that later on when we cover event histories. The final piece that I really want to cover before we get into code is the programming model. Here's some examples of some other workflow systems that are out there. We're definitely not the first or the last. A lot of workflow systems focus on boxes and arrows, which are very declarative and visually pleasing as well. And some even use XML, which is fun. I think the issue comes with anything that starts to get a little bit more complex. And let's define more complex, right? So here is a workflow. So here's actual workflow code that I took from the sample repo of one of the big three clouds. And here's the equivalent inside of Temporal. And any sort of workflow as code system is going to have this, right? Like we should basically use established like functions and variable declarations to do this sort of thing and to test them and to version them and all that. Whereas if you have to invent your own DSL, you kind of have to invent every single piece of language syntax that's been already invented over the past 40 years. Plus, you're basically, as a developer, like the experience is that you're writing the abstract syntax tree by hand. And that's not really the situation you want to get into. All right, so we're going to get into our first workflow. I think let's actually just kind of look at some code at a high level, and then we'll actually start running the code on Gitpod. So a workflow is in the TypeScript SDK is just a function, and just is a loaded word, obviously, but we try to make it as simple as possible in a mental model. And we borrow a lot from React in the API design as well. There are two things to take note of when you sort of declare a function like this, that there's a workflow type, which is kind of the name of the workflow, meaning like, my workflow.name equals a string of my workflow. And it takes in arguments and it returns a result. It doesn't have to return a result, but you can if you want to. So there's also a workflow implementation, right? So the main thing I want to establish here is that basically these two things are kind of split up by the system once you've sort of entered it in. The worker registers the workflow type by name, and then runs the workflow implementation whenever that workflow is invoked. And we'll see that later on as well. All right, let's talk about clients and workers. So this is the client syntax. Basically, we're just saying client dot. Okay, this is old actually. It's just client dot start now. So I actually need to fix this because this is a little out of date. But it's just client dot start, and then we're going to have the worker code. This is not out of date. This is correct. So then we're also going to create the worker as well. These are inside of two different processes. So the client would be inside of your overall system or your overall application. For example, we're later on in our Next.js application, we're going to stick our client inside of a serverless function because it's relatively lightweight. And it's just, you notice that it's just calling that example workflow, either just like dropping in the definition or by the name, or by the string name of what it is. And then we're also going to have the worker that just has an understanding of where all the workflows are at. This will be much clearer once we actually open up the code. So the main mental image that I want to show you or have you be really extremely clear about is this separation of what service goes where, which piece of code goes where. There's sort of three main locations that you kind of need to worry about. So one is the temporal cluster that is run either by you or by us. One of the benefits of being open source is that you can run exactly what we run. And that's something that we're very proud of and very committed to, because we have very large companies that are not paying us a single cent that are running us open source. And that also means that you can take over if you ever scale beyond our needs, or if you ever diverge from us. And they communicate via gRPC to these two other systems. The first being your microservice, your app. And I really want to show you that the temporal clients are embedded within your app, right? They're sort of part of that overall service, and we have to talk about that, how to configure that gRPC connection in production. And they're separate from temporal workers, which are scalable. And all of these are scalable. That's why kind of there's like the multiple boxes there. They're separate from temporal workers, which can host either workflows or activities or both. And basically the clients give the instructions on how to execute, on when to execute, and how to coordinate the data and state changes. We'll get into a little bit more about that, but I'll just kind of get into activities and then we'll get into code. Okay, so I want to pause here. Any questions so far about like the overall system, overall workflows? Feel free to unmute yourself if you want to, but also you can just type questions in the chat. I will have some elevator music while we wait. Anything? Crickets? Anything? No. Okay, people seem relatively happy. I have this little soundboard, so I'm gonna, when I ask people for questions and they don't have any, I'm gonna play some crickets. Yeah. So we'll go ahead and go into workflows versus activities. This is something that we deal with all day long, but when we had our design partners come to us and ask us questions, we realized that I really need to drive this home, the difference between them, what code goes where. So an activity is also kind of just a function, and again, just is kind of loaded here, but it's a function that runs inside of the standard Node.js context. So it doesn't have the deterministic limitations that workflows have, and we'll talk a little bit about that. And you can basically copy and paste existing Node.js code into activities. And I think that's a very interesting feature of migrating code to Temporal. Like essentially you can migrate your existing Node.js code into activities, and then you write the workflow code fresh that coordinates those activities. And the workflow code has to be deterministic and pure and all that. Not pure, but deterministic. And it orchestrates the activities, which are individual pieces of stateful and side effectful code. And we'll talk a little bit about how to split that up later on. I have a question here from Remy Carton. Remy says, since the app only calls to trigger the workflow, if I understand this right, if using a language without the Temporal SDK, would it be hard to implement the gRPC call? Okay, this is a common question, and we do get people asking that. So say we implement the workflows and activities in TypeScript, but trigger the workflow from an existing Python service. This actually is possible, and some people may actually, if you're good enough at gRPC, you might want to do that, but we don't encourage it because our SDKs are not simple gRPC wrappers. And you do need to take care of things like sort of reconciliation of state when you need to do that sort of thing. But the bulk of that work comes inside of a worker. So if you just want to trigger a workflow, that might be good enough. I don't actually know. And Maxime, who is our CEO, is actually in the chat here, and he might be able to answer that. There you go. Yeah, so foreign function interfaces, or whatever you call it. So Jacob here from Datadog, hey, is an expert, and he's probably already done it. Yeah, so if you want to build yourself a sort of Python client, as a backdoor, we don't officially support it, but it is possible. And let me sort of save you the trouble of research. If you want to explore this path, I'm just going to go ahead and show you where to access the gRPC. So I think it's temporal.io/API. So I'm going to drop that in for you. So here are all the protobuffs that you can sort of refer to. Oh, there you go. Thank you, Tiho, for providing that excellent TA support. Okay, So hopefully that answers your questions. Yes. Okay. There's some questions going on by the more advanced people, but I'll just kind of leave them be. Let's talk a little bit about. So we talked a little bit about how activities run inside of the standard Node.js context, and you can basically port, like, lift and shift your existing workflow code over. I find that a very appealing thing because I can just prototype like I'm in a standard Node.js function, Node.js context, and then think in terms of temporal. I think it makes sense to break up, any sort of individual action into any individual unit of activity. And then let's talk about how the workflows talk to activities. Workflows proxy activities, and that's a very intentional name, a little bit controversial of a choice. But essentially, what we wanted to do there is we wanted to show you that this is how you sort of bring in activities into the workflow context to call. And I think that's it's important for us to stress that you're not importing the activity, because essentially what these are doing here, what the worker is doing here, is that it's hosting workflows and it's hosting activities, but they're kind of in separate contexts. The workflows are running inside of an isolated VM, and activities are running inside of Node.js or whatever other JavaScript runtime we decide to support in the future. And so basically, this is an instruction to the worker to invoke the activities on the other side, and that's kind of how it's run. All right, so I just want to show you this really fun animation. We're kind of working on this with one of our illustrators. So the client calls the server calls the workflows calls back to the server calls back to activities, and then sometimes it may return back to the client, for example, if it's asking for the results of the workflow. So this is a work in progress. I just wanted to include this just because it's kind of fancy, but it really has that mental image kind of drilled into your head, right? Because once you've seen something like this, you really understand that there is that clear separation, and it's that sequence of events that kind of goes on. And I'll show this to you the moment we dive into code in about 2 minutes. So I'm going to drive this home. What workflows versus activities? What is not allowed in workflows? There are a bunch of, we always talk about deterministic limitations. And basically it's just anything that has side effects, or that might be different, when we call them again, because workflows are designed for replay at any point in time, right? And we need to be able to lock down every single part of that environment. And that's why the TypeScript SDK is kind of like unique in that in Temporal's offerings, because we've actually spent about a year of R&D on providing this sort of deterministic guarantees so that you can do replays of workflows. Okay, so what's not allowed? File system access, network access, node built-ins. That's just basically a proxy for file system access, right? But that also includes process.env, which is interesting, right? How do you access secrets and API keys inside of workflows? And we can talk a bit about how that works. And we also, and we would normally not allow things like math.random or date or set timeout. But basically what we've done is we've given you deterministic versions of each of these. So we've mocked that out for you internally. So what's fun about this is that basically you can use standard Node.js libraries inside of your workflows. And as long as they use these sort of globals or parts of the language, they will actually just work, which is pretty cool. And that's pretty nice as well. What is allowed in activities? Everything in Node.js. Fun. We do recommend item potency. It's not strictly required, but it's very strongly recommended. And we have design patterns for a lot of common questions that users have, like dependency injection, like dynamic invocation of activities, and sticky activities. So we'll cover some of that as well here, even though those are a little bit more advanced than what I have planned. So let's see some code. You can code along as well. So the typical creator starter line is npx at temporal.io create latest my app, and you can run that locally, but you do need to use Docker to run Temporal server alongside. My preferred way for demos is Gitpod, primarily because also I'm sort of live streaming, so I don't want to kill my computer running Docker as well. So Gitpod is a separate startup that is sort of hosting code as a service or whatever that is, and we've actually done some work offering you some presets. So it actually pre-builds your environment and sets it up for you. And so it's nicely automated. I'm going to drop that link actually in the chat. If you want to code along, you're totally welcome to code. I see a question from Eric Fu. Eric Fu says, do people normally run the workers and activities in containers? They can. The choice of containerization, we basically don't have an opinion on your sort of deployment model. So notice we didn't say anything here about containers. Like I even struggle to say microservice sometimes because it doesn't have to be. Yeah, we don't have any opinion on your deployment model. Even temporal cluster can be deployed as a single binary, even though that's not what we recommend in practice. Eric, did I answer your questions? If you want, you can just jump on and unmute yourself and actually ask for clarifications. Callum, no, temporal clusters cannot be deployed serverless. There are a bunch of reasons why, but essentially they're internal services that need to keep running. Yeah, and it's pretty heavy duty. Task queues, yes, but also if you want to look at the internal architecture of Temporal, we do have some talks about it. So primarily, I think I'm going to guide you to cluster architecture, and we'll talk a little bit about the service and what goes on inside of temporal services. So yeah, this is a bit too advanced for this workshop, but I'm happy to answer it at the end when we have time. Okay, Eric, I hope I answered your question as well, but feel free to shout out if not. All right, I'm still trying to figure out like this automation, and this is just not. Oh, it opened my old session. I'm so sorry. Okay, sorry about that. Okay, let me kind of fix this. So when you open up, you should actually get like a nice little welcome screen like that, and it kind of guides you through the environment that we have. I need to fix this. This recently broke because they updated some bugs that I was adjusting for, and now my bug fixes are not working because they were adjusting for things that are no longer running. Okay, let me open this up as well. So this is the running environment, and this actually reflects the samples repo that we have. So this is going to be a lot of your Bible once you get serious about Temporal. And this is where I strongly recommend people that basically just study working example code that we've done up for you so that you can kind of see how this all works, and obviously all of this runs. So we're basically what we're doing is we're opening up this repo inside of Gitpod, and it's all available here. And we're just saying, we're just going straight to the hello world example. We've opened up a README as well. On the right, we've opened up Temporal Web, which is kind of the primary debugging and visibility tool for Temporal. I've already set up Temporal to run a workflow. And it's in the process, it's in a state of running, but it's actually not completing. And we'll talk a little bit about why. So but before we do that, let's actually give you a code base overview. So this is the hello world sort of example or module, and inside of here, basically there are sort of a few keys that you want to take note of. There's the worker. Let's just talk about the workflow. So the workflow is a very simple one. It's basically a simple function that calls a greet activity. The greet activity is proxied with some settings that we're going to talk about later. The greet activity is just returning hello world. It's just doing basically basic string concatenation, and then it's being called inside of the workflow. Yep, right. Then the client is located inside of this little node script called execute workflow. We're going to rename that in a short while. And that's calling client.execute here as well, together with some arguments, a preset workflow ID, as well as a task queue. We'll talk a little bit about all those components towards the end as well. And then finally, it's run inside of a worker, which is persistently running, where it says basically it runs both the workflows and the activities on a task queue. And then we call worker.run. That's essentially it for the entire code base of this thing. Inside of my terminal here, I have set up two things. One, which is that I have run one which is I have run the workflow on the right, and then the next one is I can run the worker. So here I have it set it up with a script. So if I run npm run start watch, and that's going to start off that worker. And we're going to start to see this complete. So notice that because Temporal server is running in the background, this is Temporal server running in the background, we actually were able to log the start of the request even without a running worker. So now if I refresh this, I think it's gonna show that it's completed because I have kicked off that workflow. Yeah, there we go. So now you can see that not only has this completed, it's actually done that string concatenation and said hello world back to me. We can also go through some of the history events. So let's say these are all the histories that are generated during that time. Because this is such a simple workflow and we're only doing string concatenation, there's no time elapse between all of them essentially. Like it took us a while to start the workflow and start the worker to execute that workflow. But beyond that, the workflows, activities, and then everything else executed immediately. And you can see the complete history right here as well. So there's some questions going on in the chat. Basically, it's Callum asking, why does TypeScript SDK require ID? Other SDKs do not. So it was a sort of a group decision by us because we wanted to guide you towards best practices. And the best practice in production is that you do want to specify a meaningful workflow ID, because all we were doing in other SDKs we were auto-generating a UUID for you. And that's not super meaningful. And yeah, so we wanted to remind you to do it. Having an ID, by the way, this is where the ID shows up. It shows my business ID, but here you can probably tag it to a user or a transaction or whatever, something that's meaningful, like a deployment hash or whatever that is. We strongly recommend having that as a business meaningful ID. Okay, so that's the rough orientation to Temporal code base so far. You can run even more workflows. Just kind of run npm run workflow. I'm running it on my terminal on the bottom right, and that's going to execute yet another workflow. This time I don't have to wait at all because I have my worker already running. And you can run as many of those as you wish. This is just obviously running it within a script, but obviously in real life you're going to be running it inside of your app. Okay, any questions so far? I'm going kind of slow here because I really don't want to lose anyone. Have we talked about the difference between workflows, activities? Have I given you enough of an orientation around clients and workers and workflows and activities? I hope all of that is clear, because I can't proceed if I haven't established that. Any questions so far? I'm happy to answer them. No. Yes. All right. Still getting crickets, but I like that people are asking questions in the chat. Callum, all right, questions. Let's see. Callum says, should client be specified once per server instance? I don't know what server instance means here. What does server instance mean? Per microservice. Yeah. Yes, there is, it's not, depending on how performance sensitive you are, it's not free to set up a client. There's some init costs, but most of the time you can kind of set it up once per microservice or service function or app. I think if you have an app, yeah, I probably would recommend setting it up once. Yeah, I think I know what you mean. Yeah, so yeah, try to set it up once per app. Okay, cool. Eric Norman has a question. Remy, I'll get to yours next. What happens in the client when the activity fails? Very perceptive. Okay. And Remy Carton says, what happens if I publish a new version of the workflow? I think both of these questions are very apropos, and we can probably answer them down in the next section on timeouts and retries. So Eric and Remy, I'll try to get to you once I cover some of this content here. All right. And then final question before I move on is from Eric Fu. Eric Fu says, my question around worker deployment is related to this page on determinism. Yes, the famous page on determinism. It says that the temporal TypeScript SDK runs each workflow in a separate V8 isolate, a sandbox environment with its own global variables like the browser. So just kind of like we explained, the workflows have deterministic limitations, and the way that we choose to do it in the TypeScript SDK to provide you guarantees against shooting yourself in the foot from non-determinism is that we choose to run you in a sandbox. Are these automatically taken care of by the SDK? Any additional configuration needed when deploying workers in a container? No. We have a production deploy checklist that you can check out, Eric. So with some of our recommendations, but not much in the way of configurations. You may want to pre-build your code because you're writing it in TypeScript. So we do recommend pre-building it, but that's very simple standard Node.js production stuff that you should be familiar with if you're doing TypeScript in production already. Yeah, nothing beyond that. I don't think. I will shout out if I can think of something because I haven't had that question asked me in that way before. All right, let's get to your questions, Eric and Remy, and we'll talk a little bit about failures and how we handle that in Temporal. So this is part 4. This is part 4 of 7, so we're making very good time. This is about timeouts and retries. So this is a image from a blog post that I worked on together with Maxime, basically talking about how we think about things during the 3 phases of an activity, meaning that we can schedule them to start, and then when they actually start, and then when they actually close because they're completed. We have 2 primary timeouts that you should be aware of most times. There's this sort of schedule to close timeout, which governs the gap between the scheduled state and the closed state, and the start to close timeout, which covers the gap between start and close state. So basically, this governs all overall execution time, including retries, and the start to close timeout execution covers the time for one execution. So essentially, scheduled to close is always longer than start to close. So we'll actually talk. I'll just show you the API, and then we'll kind of get into the code. So this is an example of the API. So that proxy activities function that we talked about earlier is right there. But here I've expanded the options that you can set to really show you the full range of what you can set. Obviously, there's actually even more, but here's the typical range of what you might want to meddle with. So I just want to give you that orientation first. So for example, we'll say start to close of 30 seconds. That actually is kind of long if you're making a typical API request. And then schedule to close inclusive of timeouts, let's say some multiple of that. And we'll talk a bit about the intuition behind setting retries and timeouts. Setting a retry policy, here are all the defaults. There are sort of 5 main levers that you can pull. So the initial interval, the backup coefficient. So these are all sort of best practices in terms of exponential backups of retries, so you don't have a retry storm on yourself, as well as setting maximum attempts and all that stuff, and as well as a special instruction that you can give from your activity and saying like, okay, this is an error, but I don't want you to retry on this error because this is a fatal error. For example, my the thing that I'm wrapping is down permanently, so just don't even bother retrying. There's a question of whether or not we do jitter, and as far as I understand, we do have de facto jitter, which is very nice as well for retries. Okay, example 2, no retry. So here's an example of how we tweak some of these policies to model the behavior that you may wish for your retries, right? And note that all these are very declarative. So let's say I want to guarantee no retries. You can just set maximum attempts of 1. And so it's just gonna attempt things exactly once, and then it's gonna stop trying at all, and it's gonna fail if that activity fails. We don't recommend this, of course, but this is just a way to model a standard behavior of like trying something in Node.js, and then if it fails, then the whole script should fail. How about linear retries? You can tweak the backup coefficient to 1 and not 2, so the exponential is just 1, and then you have a max attempts of 5. So these are all just examples of setting. Maxime chimes in the comments about the jitter. Max says, we don't have jitter, but it is not needed as activities are delivered to workers through task queues, which are flow controlled. So workers cannot be overloaded by retries. Yeah, so that's what I mean. So we'll talk about task queues towards the end. I'm basically like kind of eliding over task queues, so we can talk about business logic for now, but they are important core concepts of Temporal. All right. So the net effect of having these sort of declarative retries by default and all that, retries and timeouts by default, is that we have what we call fault oblivious workflows. In a sense that if you look at the workflow function down here, you're writing my workflow and then you're saying like charge, the customer something, and then you're returning it. You're writing as though the API never fails. But behind the hood or under the hood, Temporal actually takes care of that and actually gives you an API to declare your timeouts and retries, so it handles all of that for you, right? So it's fault oblivious in the sense that we've basically separated that concern into a different plane that handles retries and timeouts. This can be a revelation for some people, and also this is obvious to others. So I don't know where you guys are at in terms of your understanding, but I think this is a nice way to explain what we mean by fault oblivious. I did not come up with that. Maxime also came up with that. So please let me know if I misrepresented it in any way. Okay, so let's talk a little bit. Let's actually simulate that and answer comprehensively the questions that were raised earlier. Before that, I have a question about rate limiting. Yes, we can. There are a few ways to do it. If anyone else has a question, I will get to that in a bit. But I want to answer the thing about failures first. So let's actually write an activity that always fails, right? So I'm just going to make this activity always throw. So I'm just going to delete all these comments, which are internal. And I'm just going to say this activity always throws a new error, activity failed, right? That's going to reload automatically because I set up my worker to reload. And now I'm just going to go ahead and run my my workflow again. And I'm going to run my workflow in the bottom right. And that's actually going to block for me until it finishes. And now you can see my activity, my workflow is running, but it hasn't completed like it normally does. And there's this new field inside of the UI that says pending activities, and it's already on attempt number 4 because basically some time has elapsed between the time I hit enter and now. So what is the failure? We can actually go into the history, I think. Oh, we can actually see it right here. It says error activity failed, which is exactly the error that I hard-coded into that activity, right? So basically we have deployed a buggy function. We've either deployed a buggy function here, or the service that it's calling is failing, right? So here in this situation, we do happen to have deployed a buggy function. So what I'm going to do is I'm actually going to fix it by commenting out that error, and I'm going to save it. The worker is going to reload down in here, and when I refresh this, it may still be retrying. I'm not sure actually. Yeah, it's still retrying. Oh, I think it's about done. Okay, it's scheduling the activity, and now it's completed. So essentially, like, it was pausing, or it was kind of in that retry state until I fixed my work and deployed a new version by reloading my worker, right? So this demonstrates a bunch of different concepts at the same time, in a sense that Remy Carton was asking, what happens if I publish a new version of my workflow? Here, I publish a new version of my activity, not the workflow, but it's pretty similar. It basically replays that. Here's sort of catching the new activity version in a retry. If I deployed a new version of the workflow, we can actually try that later on. If I deploy a new version of the workflow, we'll just kind of replay logic until that point. And you have to take care of migration as well if you're doing stuff in the workflow. And Eric Norman asks, what happens to the client when the activity fails? The client basically waits or doesn't wait, depending on what you told it to do. So here the client is waiting because we told it to wait with the client execute call. But if we told it to not wait for the workflow to complete, we can say client.start. So those are the two primary APIs to do that. In fact, most of the time, I think you'll be starting with client.start anyway. So Eric, I hope I answered your question. And then Remy, I'll get to your question in a little bit. I just want to double check that the others as well. All right. So Gregory Warner asks, when things go wrong, can activities differentiate to the temporal server between conditions that should not be retried, 400 class errors, and conditions that should, 500 class errors? So yeah, activities can throw different kinds of errors. So let's go into part of that docs. And that's what we call a non-retriable error type. So let's actually go into the API reference. So apart from these sort of human readable or human written docs, there's auto-generated docs, which are the API reference. And this is where you go if you need source of truth on a hierarchical and alphabetical reference on data. Because here we try to give you an opinionated view on the APIs, and here we give you the full set of APIs. And over in the full set of APIs, we actually have a bunch of, oh, I don't think this is the right place to go. Activities. There we go. Is this what I'm looking for? There we go. Retry policies. Okay, got it. It was nested, and I forgot. So you can actually tell Temporal like, hey, when I throw this special class of error, do not retry, right? So I will say if like basically I'll just do some pseudocode for you, Gregory. So we'll say something like fetch blah blah blah. Await fetch result equals await. This is pseudocode, okay? It's not supposed to run, but whatever. And then like if rest.status is like 500, and throw non-retry. This is fatal, whatever. And this error would be something that you maybe define yourself. So let's say, this would be like a sport class extends error, and then you could define that internally here. And then within the client itself, or within the workflow itself, you would also import something like this, like import, and then you'd say retry, types, yeah, something like that. So that's kind of the pseudocode that you would need to implement something like what you're saying, Gregory. Did I answer your question correctly?
Yeah, thanks.
Awesome. Thanks, Gregory. That was a great question, and something I wouldn't have covered if you didn't ask. Okay, Eric. Eric, we have even more questions. They're all piling in now. I'm amazed, and I'm very happy because it shows that you're really thinking about this. Eric, can a client reconnect to a running workflow, like if a client is redeployed while a workflow is still running? Yeah. Yes. So we have an API. We haven't got to this yet, but essentially, you can sort of retrieve any running workflow by their workflow ID. We have client.execute here, and we've sort of asked you to specify your business ID, but we can also say, for example, if there's already one running, you can say something like handle, and you just kind of give that business ID there, and this will have all the methods that you might possibly want on a running workflow. You can cancel it, you can describe it, you can get its result, you can terminate it, signal it, whatever. All right. So that is a question from Eric. All right. So next question from Max Brosnahan. Can we import from activities in workflows? Yeah. So I did this, but notice that this was not an activity. This is an error type. So we could actually probably have a common file called error types. But no, we explicitly do not want you to import from activities into workflows, right? That's why we have this sort of proxy activities. It's kind of awkward because that's the way we communicate across the different environments. Activities run in the standard Node.js context, and workflows run in the deterministic sandbox that we provide to you. All right. I hope that was, I hope I fixed my code because I screwed it up with a, unscrew this code. Give me 1 second. I'll get to the rest of your questions in a bit. I just need to make sure that this code is runnable. Otherwise, it's going to screw up my demo path later on. All right. Okay. I think this runs. All right. More questions. Pranav, you have a question about, is there a way to define progress within a workflow for reporting back to the user? We do have an example for that. And I think it's actually literally called progress. This one. So I think we have an activities example. I need to make this clearer. I'm sorry about that. Yeah, no, that's activities heart beating. Okay. Probably the way to report back progress, I'm not sure what I would recommend as a general rule. Yeah, okay, we'll use queries. So Pranav, yes, we'll use queries to do that, and I haven't introduced it to you yet. So we'll get there. Okay, and then I hope I answered everyone's questions. Please shout out if I did not. It looks like I did. I want to address a little bit, a loose end that I left for Remy. So Remy's question was, what happens if I publish a new version of the workflow? So I only partially answered that question. Okay, so I showed you what happens when I want to redeploy a new version of the activity, but I haven't done that for workflows. And essentially workflows, like Temporal server, doesn't care what the implementation of a workflow is, right? It wants to give you those inputs, and it wants some outputs, and it has tracked the event history of everything that happens within there. The thing about this to know is that if you, oh, sorry, I accidentally hit reload on my screen. Thank God for browsers, which are relatively fast and performant. So the only thing that Temporal cares about is that this workflow history is executable or replayable on your workflow function. So in a sense that like that's the whole point of that determinism. Like if your worker or your Temporal server, if any part of your system fails at any point, we just bring it back up again and replay the entire event history up to a certain point to retrieve that current state and then carry on, right? So that's how you need to think about determinism. And if you need to break that event history flow, if you need to sort of introduce more control flow inside of your workflows, then we have a migrating or patching API. We used to call it versioning in other SDKs. With the TypeScript SDK, we're kind of moving towards a new type of versioning, which is simply telling people to patch in new code alongside of their old code. So this is a bit more advanced that I'm not covering here, but we do have examples for that and the whole doc that covers migrations of workflows. And obviously this is a super important thing, especially with long running code, because you need to run new code alongside old code a lot of the times. The main thing I'll say is like, maybe you may not need, like a lot of simple use cases don't actually need to patch. So we actually talk about like, you may not need this at all. You can just kind of do workflow 1 and workflow 2. And then once workflow 1 is done, you can just put all new traffic onto workflow 2 and that's it. In a sense, that's the most dumbest form of migration you can possibly do. All right. There was a bunch of questions, so I'm going to answer, check the chat a little bit more. There's a question from Max Brosnahan. Max says, are there any linting tools to help prevent developers from doing things wrong? As a developer experience team, I think in future we will be we'll be trying to build that. Right now, we do not. So you may have to develop that on your own. Obviously, we welcome contributions on ESLint or whatever that front. But right now, we don't have the capacity internally to do it yet. Obviously, it's helpful. Okay, Daniel Reardon. Question from Daniel. Piggybacking on Remy's question, if workflow code is shared between client and worker code, it's possible to call client execute with an older version of the workflow code. Would that cause issues, or is only the workflow name relevant? Yes, only the workflow name is relevant. So this is very sharp from Daniel, right? What he's saying here is essentially that like all these are deployed in separate processes, right? I have this embedded inside of my app, which is like my clients, and this client is calling my workflow, which I call example here, and it looks like it's just calling that workflow, but really what we're doing internally is we're just saying workflow function.name. The reason we sort of guide you to do this is that it provides type safety, in a sense that if I forget to provide you this string, it actually gives you a type error, and it says, hey, I expected an argument here and you didn't provide it. And that was inferred from the definition of that workflow down here, where it says, I expected an argument called string. So we really like that type safety. This is why we are called the TypeScript SDK and not the JavaScript SDK, because it's so easy to shoot yourself in the foot when you do stuff like this. But ultimately, yes, under the hood, Temporal communicates via gRPC. It only sends the string names of, the client only sends the string name of whatever it's invoking, any arguments serialized down to the server, and the server also invokes it on the worker. So on some level, yeah, actually, you kind of are not sharing that implementation. Daniel, I hope I answered that question for you. Also, feel free to ask some follow-ups as well, because it's really clear. It's really important to me that you understand this as well. All right, Callum has a question. I think you mentioned that TypeScript is unique for Temporal SDK because you guys can ensure that developers aren't creating non-deterministic workflows. Can you offer some safety around other SDKs, or maybe I'm misunderstanding what you meant? Yeah, the other, Tiho can probably answer you here, but essentially it's possible in future. Right now we do not, and there are non-deterministic errors when you do that. So there's just like a rules of, you just have to kind of keep it in your head as you code when you write some of the other SDKs. Oh, perfect. We have one answer for Go and one answer for Java. So yes, there's a work in progress, but right now there isn't in the other SDKs. We hope that every other SDK from now on that we develop in future will have all these guarantees done for you, so you don't have to worry about it, or you have nicer errors. And then for Go and Java, or our existing SDKs, we may have to develop some separate tooling for that, because I don't think we're willing to rewrite it from scratch. Okay, so that is where we are at. We're going to talk about workflow APIs, and I went to the effort of putting in some memes here, this because to me, like, this is kind of where you start to really have fun, right? It's like, okay, we just learned a whole bunch of things to say hello world, right? Like, yes, it's very reliable and distributed and fault tolerant and whatnot. But also, like, tell me the cool stuff that you can do once I'm in a workflow. I did the hard work of porting my code to a workflow and activity paradigm. Tell me what that gets me, right? And this gets you some of the really interesting stuff that Temporal really unlocks, and the model unlocks, because we have a central runtime that has those timers and has that persistence, and is basically scalable. So the first API that I want to show you is our timer API, which is basically workflow.sleep. It takes a string or a number of milliseconds. I obviously prefer to use strings, as long as you don't get too funky with the strings. It's interpreted by an open source library called MS. And so here is an example of like an installment payment workflow. Like, I can charge a card once and sleep for 30 days and charge it again. This is typically what we lead with in our landing page, for example, because it catches your eye and it starts to make you ask the question of, why do we not do things like sleep 30 days inside of our code? And it's because our process can go down, and it's irresponsible to do that unless you have an abstraction like Temporal, where every call to an SDK is persisted within Temporal service. So essentially, it's actually not blocking the process itself. Once you call sleep, it's actually deferring execution. So this is extremely scalable in the sense that you can have a million simultaneous durable timers set, all running at different times, and waking up at the exact time that you told them to wake up, plus minus obviously some network stuff. But I think that's a immediately impressive thing to show you. Max Brosnan had asked, what is workflow.sleep doing under the hood? Is it throwing an exception until time has passed the desired time? That's an interesting idea. I wonder if you got that from React Suspense. Sorry about the Slack ping again. I need to turn off my Slack notifications one more time. Okay. So no, it is not doing that. Again, this is a function of us controlling the SDK for you, and the deterministic workflow runtime is that we are able to provide you magic like this. But I'll show you how that works in terms of the running code. So just give me a second, and I'll get there for you. This question is about Adam. Can you overwrite a workflow logic in the middle of workflow.sleep, and what are the side effects? So yeah, you should be careful about that. You should probably use some patching logic, because you can kind of go through that Q&A if you want to think about whether you need to patch it. But yes, you can overwrite it if you need to, and control the side effects if you need to. But if essentially, if like you want to update something, if you want to update immediately what happens after the sleep ends, then you don't have to do any patching at all. You can just kind of immediately update it. You know what? So I'll show you one more thing that you can do with the sleep, and then we'll actually just go into the timer, because we have so many questions about timer. I need you to understand this before I move on to signals and queries. Okay, so just one fascinating thing about timers is that, and the temporal environment in general, is that we suspend on all these API calls, right? And so you can actually do a subscription workflow just with a while true, like infinite loop. Doesn't matter, because you can charge the card and then sleep until, this is a custom sleep until function. I provide the boilerplate for that inside of the code. You can sort of construct that out of the primitives that we give you for workflow.sleep. But this is a simple workflow function. And for example, if you ever need to cancel, you can call workflow.cancel from the client, from externally. But a very simple implementation is this, and I think it's kind of mind blowing that you have your activity here, you have your timer here, and you can kind of call an infinite loop there until a certain point of exceeding the event history limit. And that's something that you can get to when you get into really learning temporal. But I just want to give you that mental model in the first place. Okay, let's actually try out these timers, and then hopefully give you more of an intuition about like what they do, what they're about, so on and so forth. Okay, so lots of questions. Eric says, what happens when the customer cancels their subscription? You know what? Let's do it. Let's write subscription workflow live, unrehearsed, and it'll be a fun high wire act. But first of all, I want to show you how the timer works in the first place. So I'm just setting up my environment so I can show you. I'm going to do some things to optimize and sort of clean up this example. So I'm going to say import stars workflow. So I don't want to do individual imports, and I'm not going to use activities. So I'm just going to clean that out. I'm just going to click here, and this is the only workflow that I do. Okay. Okay. All right. I'm just cleaning up this example so that it's kind of clean. All right. So we're going to say, for example, something like console.log starting, and then workflow.sleep for 1 second, for 3 seconds, and then console.log ending, right? All right, so I've done that. It's my worker has reloaded because I saved, and now I'm going to kick off the workflow again manually. Again, this would be embedded inside of a API call from my microservice or whatever, if that is going. And let's actually see that sleep in action. So if I refresh this, it doesn't refresh. It doesn't auto refresh right now, which is disappointing. But we hope to fix that in the new version of our UI that's coming out next year. Okay, so here's a new event that we implemented, which is the timer started event. It's got 3 seconds on it, and it waited for that to execute. You can see that the logs that we have are in here because I sort of logged them from the workflow. So over here I have starting and ending. If I wanted to, have an activity that logs out somewhere else, I could probably have done that as well. But I'm just keeping it here for simplicity so that you really understand what's going on. So let's go for a bit of a more aggressive timer. I'm going to say 30-second timer now. And I'm going to kick off that workflow again. And then I'm going to do something drastic. I'm going to actually kill my worker. So there's no worker running anymore. I could actually even kill Temporal. And that timer in any normal system, I'm simulating a complete outage, right? Like a complete outage where I've kicked off that timer and I'm just like, completely killed it. Here, okay. here the timer is actually started, but it actually has gone ahead to complete because I don't actually have any other any other activity. So I might need to bring back that activity actually. So let me just go ahead and do that. I didn't await it. Yeah. I'm an idiot. I should actually, I don't know, put some warning in there. And I've thought about actually making this kind of blocking internally instead of being a promise. But it's very useful for it to be a promise because you can do useful things like promise.race and then put it inside of a race with other promises as well. And that's a very useful design pattern. So it's useful for now for it to be a promise. But thank you, Jeremy, for that catch. All right, let's try it again. Live coding is always fun. But also, I guess we're learning some of these lessons as we go along. So we have that timer running, and I'm now going to kill that worker. And I've just killed that worker in the middle of processing, right? I could also kill Temporal, but it doesn't matter because that timer has been persisted to my persistence layer, which is either Postgres or Cassandra or MySQL or whatever, or SQLite, thanks to Jacob. But you can see that the workflow is going to still being tracked here. The timer has started, but it hasn't resolved. I think if I restarted it, now that 30 seconds have passed, so we can see that, for example, the timer started at 11:14:47, and then 30 seconds later, 11:15:17, the timer has finished, and it's gone on. So what's happening here? Let's actually go step by step through the workflow code, right? So when I kick off a workflow at 11:47, let me see if I can do this here. It starts a workflow execution started. Then it says workflow task scheduled. So workflow execution started is when the client sort of is calling out to the server, and workflow is scheduling a workflow task, and then the worker picks it up and records a workflow task started. Workflow task is completed because that it's basically just executing this, and now it's starting to schedule this activity. The activity is that greet workflow, and it's executing that console log of hello whatever, and then it's going to the next thing, which is the timer that started, which is interesting because I haven't awaited this as well. You notice that these are all happening out of sequence because I didn't await it. This is terrible coding from me. So I do strongly recommend awaiting all those things. So in a normal world, we'll be waiting for the activity task started to complete, and then we'll start that timer. The timer starts and it's persisted, and then we're also scheduling the next workflow task for it to be going on to the next activity. But the second activity for starting, the first activity is for starting, second activity is for ending. The second activity has not been called because my worker is crashed, right? I intentionally crashed it. So all I need to do for this to finish is I can bring it back up again. So I'm bringing back up my worker, and I can show you where it's brought back up as well. So when the moment it's brought back up, it should, let me see if I can expand this a little bit more as well. The moment it's brought back up, it should actually complete that overall workflow. So you can see here that it might be if I switch to time elapsed. Right. So that timer fired while my worker was down, and I brought it back up, but I couldn't proceed. It couldn't proceed to complete all the remaining tasks and activities that it was assigned to until I brought it back up 1 minute, 54 seconds afterwards. So this is a very high visibility log of what's happening throughout your system, spanning across all the services that you might interact with. So hopefully that gives you an idea into the observability story behind what Temporal brings to the distributed system. Obviously, there's also the observability question of Temporal's workers itself, which is a separate question that you do need to take care of when you're running it. But hopefully that gives you the question of like, does Temporal throw an error to suspend this timer or anything? No, it's not anything like that. It's not like React suspense. We just happen to control it. And we stop that execution there. Okay. There's a question here. I'm going to catch up on questions because I took a detour. There was a bunch of questions. This is excellent as well. So Ralph asks, when testing, can we inject a clock so we don't actually have to wait for 30 days when running our tests? So yeah, this is a very pertinent example of why it's useful to have a framework for this stuff, because then you can implement time skipping tests. We have this in the other SDKs, but we do not have this yet for the TypeScript SDK. So, which is one of the reasons why we regard our TypeScript SDK as beta, not general availability. So we have Tiho actually has a really good video. Actually, is it Tiho? No, I think it's Val. So I think in our Go docs, we have a really good example of how this time skipping testing works. So, I think it's on our it's on our YouTube. So I'm gonna go ahead and I thought I embedded it somewhere, but I think it has been moved around a little bit. So it's on our YouTube, and I think it's called Move Fast Without Breaking Things. And this is just a recording. Oh, yeah, it is Tiho. So we have an example of how the time skipping works here. And if you want to think about the testing, yeah, I think it's a really good idea for testing because we happen to have all control over your sort of time skipping APIs. Okay, great. What happens when customer cancels the subscription? Okay, well, we're gonna go into that, Eric, because I think that's important to understand before we move on. Yeah, so we don't have time skipping yet, and that is one of our we do not have time skipping tests yet. So that is one of our to-dos for general availability. We do have other recommendations for testing. So you can check out our testing docs down in here, but we just straight up do not have a sort of test story beyond standard Node.js testing. I mean, obviously the library itself is internally tested, so we're basically exposing that to you. Adam says, with this example, I'm imagining you would associate the workflow instance ID with the user, and when they cancel, you would use the client to cancel the workflow by ID. Yes, that's exactly correct. I'll show that to you when I write up that subscription workflow. Kirill says, is there a good pattern for aggregating state in a workflow? For example, as a workflow, let's say we want to aggregate some number of notifications and send them as one email. Would each notification be a signal? No, actually. Oh, Kirill, oh, this is perfect. You're gonna love this. So what you do is you declare local state within a workflow, and it's gonna that's one of our main value propositions. So like notifications, I'll just call this an array, and I can just say like notifications.push some message one. Push a bunch of messages, and then by the end we can just send like say something like wait, send email notifications, something like that. It's just a really great way. And obviously you're doing some logic here, you're doing some logic here, you're responding to some events that are coming in by signals. It's just a really great way to have that local state be tracked within the workflow and managed for you entirely. So you don't need to call out to a separate database or anything. And that's part of the fun of putting state inside of Temporal, but you should not go too crazy with it because there is a serialization cost for all this. So if you care about performance, that is an issue. And there's gRPC limits. We document all of our limits here. Limits, server limits, there we go. So there's blob size limits. So if your data starts to get to 512 KB, we start to warn, and then we have a hard error at 2 megabytes, as well as the overall gRPC size limit of 4 megabytes per messages. So there's some sort of hard-coded server limits, all of which are configurable if you need to know what you're doing, but we don't recommend overriding those. We set them for a reason. Okay. All right, Max Brosnahan, how do I check how much time was actually spent in the timer? For example, I don't want to continue the workflow if the timer was 5 minutes late. So this is kind of like a timeout question. So a promise.race is probably a nice pattern to have. So let's actually just use the docs for that. So where to find it in the workflow docs? The workflow docs has not just how to write a workflow, but also all the workflow APIs. So hopefully you can find everything that you need here. So we have some design patterns that we document for you. So for example, using promise.race. And if you want to say like, oh, do this or do this first, whichever comes first, and you can sort of handle that by composing promises the way you normally would in JavaScript. There are some anti-patterns that you need to be aware of. So for example, you may, where is the anti-pattern? Condition anti-patterns, async signals. Yeah. Be careful about code that looks like this, which is sleep for 5 seconds and then do something, or do other promise and then sleep. So if you're racing a sleep, but then you're doing a .then after that, you're chaining a .then, because this will continue to execute even if some other promise resolves first, because promises are eager in JavaScript. So this is just regular JavaScript code, but I do want to warn you about that sort of thing. And if you read our docs closely, we do document this because people have run into that already. Okay, all right. So promise.race. All right. Would promise.race work in a case where the worker was down? Which promise would win in that case? Would promise.race win when the worker was down? So time continues going when the worker is down. That's the main intuition that you need to have. If your other promise is not based on temporal server time and is based on something else and is just not executing anymore, then it would win, or the time, basically just time keeps going as far as temporal is concerned, even when the worker is down, because the temporal server is the source of truth on time. So try to use that intuition when you're debugging stuff like that. Okay, I think we've answered all questions, and I need to handle the subscription question, and then we'll continue right on to the signal question. Okay. All right. So all right. So I feel like I want to rename some things. So I'm going to go ahead and rename this to like charge card. Charge customer, I should say, just to make myself feel better about like the syntactic business logic of this stuff. And then I'm actually going to go ahead and rename I'm just going to call this subscription workflow. So now we're starting to flex the timers a little bit, but it's also going to be a nice lead in to the next example, which is signals and queries. Okay. And the last part of renaming this workflow is that I have to make sure my client is also updated accordingly as well. So yeah, by the way, I don't have to import this. I can also say, I just want to invoke the workflow by the name of subscription workflow. And that's also fine. It's just that I lose the type safety over here. I'm going to call it client.start. And the return, it no longer gives me a result because I do not wait for the result. It gives me a handle to the result. And I can just say something like started workflow. Because everything is type safe, I do have a fair amount of developer velocity when I'm writing this stuff. By the way, this connection is also, because I'm running this locally, this connection is also optional. So I can also this code, and just kind of say clients. So this hopefully starts to become a much clearer picture because I took all the comments for you. This is our worker. Sorry, this is a client. This is our how we kick off a client, and you can sort of implement this within your microservice or application or serverless function any way that you wish. The worker code does not need to change because the worker code is just given a path to the workflows as well as the activities to run in Node.js. Okay, I think we took care of everything, and now we can actually write the subscription. So now I'm going to just say exactly what I promised on that slide. So I'm going to say while true. I'm going to charge the customer, and then I'm going to say give me money, and then I'm going to sleep for 10 seconds. Why not? And I'll show you the cancellation as we go along as well. I'll actually be a little bit less facetious and just say charging customer name, and then I'll sleep for 10 seconds, and then I'll loop back infinitely until the end of time. Okay, so let's go ahead and say something like, I think we can kick this off. Did I take care of everything? I'm not sure that I did, but also let's just try and figure it out. So my worker has reloaded. So all I need to do is fire off this workflow. Notice that I changed the name of the workflow to subscription workflow. So now over here, the workflow name is going to be different. It's no longer example, it's subscription workflow. And it's just running. It's done the first charge of the customer. It's done the second charge of the customer because the second 10 seconds has passed as well. And this is pretty nice. This is it's a nice little example of how a subscription workflow can keep going. But now let's say I want to cancel it externally, right? One of the questions Eric Normand was asking if I could cancel it. Of course I can cancel it. I have the workflow ID. Here I have the very unimaginative workflow ID of my business ID. So I'm going to copy this script. And so imagine if I have a different client call, different API call, whatever. I just call this cancel, a little script called cancel with the workflow.ts. I'm going to paste that in here, and I'm going to modify what I need. So I don't need to start the workflow anymore. All I need is a handle to that workflow. Get it by just giving the workflow ID. And I can say handle.cancel. Handle.get handle. Oh, I love TypeScript. Handle.cancel. There we go. All right. And we'll say something like cancel. So when this script runs, all it does is it sets up a client, gets the workflow, but gets a handle to the workflow by the name of my business ID or by the ID of my business ID, and then it cancels it. All right, so let's see this in action. And I'll talk about the difference between canceling and termination as well. So this thing is still running, still charging my customer. Let's see how many times it's charged it already. So imagine this is a super long running workflow. It's been running for years, and it's got 103 history events. This is still fine. There is a system limit of 50,000 events, but we start warning you every 10,000 events because you do want to do if you in real life, if you actually were to implement a subscription workflow, you would have to basically truncate the events every now and then, so that you don't go over that limit. And we give you APIs to do that. In future, I really hope that we get rid of continuous new, but that's just the system as it is for now. But it's completely auditable. You can check everything that's happened. And I think it's a very nice system to have for sort of long running workflows like that. So let's go ahead and see what happens when we cancel it. So I'm going to run that cancel workflow script. For those who are familiar with NPM, this is set up inside of package.json, where I have this npm run workflow thing set up. So I need to duplicate this and just say like cancel workflow and call this cancel workflow, save it. And then now I can say something like on the bottom right, I can say something like npm run cancel workflow. Cancel that. And now it's canceled. And when I check back on the screen, it actually says this new status. It says canceled. And you can also check the history of when I sent that cancellation in. So it cancels the timer and it cancels the workflow because it was in the timer at the time. So the difference between cancellation and terminate, because that's the other API, is that cancellation lets you clean up, whereas terminate doesn't. Terminate is kind of like a forceful kill. So very similar to like other sort of async paradigms that you may be familiar with. And the cleanup code, we actually kind of document it both on the activity side as well as the workflow side. Where do I show you for that kind of stuff? So activities, and activity cancellation. This basically, if you cancel a workflow while an activity is still running, the activity can actually know about it and gracefully clean up if it's in the middle of something. So it's an optional function there, and you can also handle sort of workflow canceled errors. So and sort of gracefully clean up that way. So we do have examples for you throughout our samples. I don't need to super get into that for you now, but hopefully that shows you the cancellation paradigms. Okay, that was timers, and we have 30 minutes left. I can cover signals and queries, and then go briefly into workers, task queues, and the Next.js application. We may go a bit over. I have my schedule clear to go over, but I do want to try to deliver on that original promise of 2 hours. Okay, so let's talk a bit about signals. So signals are a way to get data in to the workflow while it is running. So if you imagine our subscription workflow, let's say we want to change the amount that we're charging while it is running. So it's like an upgrade of a plan or something like that, right? So you can basically define a signal, and then you can set a handler to that signal inside of the workflow, right? And it just updates that amount that is being charged. Here, I'm using the fact that JavaScript arguments are also local state variables that I could just update like that, which is pretty handy. And then from the client, I can just call signal back in. So getting data in uses signals, and getting data out uses queries. And they basically have the exact same API. Signals can do mutations, queries cannot. Signals do not return anything, queries do, right? And it's pretty intuitive, like if you understand that signals are for getting data in and queries are for getting data out. Okay, so that's about it. I mean, I could also show this to you and run that code, but hopefully this gives you an idea of is essentially what that question is. Does anyone have questions about signals and queries? I know there were a bunch that I skipped over earlier. Does anyone have questions about signals and queries? I mean, I can show you the code, but also like, this is kind of it. All right, Eric, you have a question. What is the design pattern for wait for a signal or timer, whichever comes first? You know, this is one thing I forgot from my slides. Oh, Eric, you're amazing. Okay, all right. So what is the design pattern for wait for a signal or timer, whichever comes first? This is very, very common, right? So one thing I love about Temporal is that it helps to handle or like when you talk about long-running processes, sometimes that involves humans, right? And it involves racing humans versus machines. It's like an epic battle of human versus machine. And I really kind of like that because I kind of view signals as like, data coming in from the real world, often from human activity, whereas the machines are just kind of active timers. Sorry, to cut myself short, the answer is the condition API. And we've basically hard-coded, this is such a common need that we basically hard-coded that for you. So here's an example of what that is. So the condition API basically says block for an indeterminate time, because the sleep time blocks for a set time, right? Like this is kind of like definite sleeps. Sleep for 30 days, sleep for a specific number of milliseconds. These are all like, if you know the sleep upfront. But what if you need to sleep for an indefinite amount of time until something is true? Then you use the condition API, where you can wait for a predicate to evaluate to true, or something times out, right? Under the hood, if you look at the implementation of the condition API, we're basically just putting the workflow.sleep there and racing it for you. But this is so useful. This is so useful. I almost want to implement this for you, but I'm also worried about the time. How about we jump straight to the Next.js code, and then I'll show you that in practice so that I don't have to code it. but then we also kind of kill two birds with one stone there. So Eric, I'm actually going to show that to you. I'm just not going to code it by hand, just so I don't screw it up. I want to answer one more question. Gregory says, if I had a workflow that had its own state, think state machine, I assume that would be exposed via query. And is there a way to add state as a column on the web UI? There's no way to add state as a column on the web UI. That is something that maybe we'll get to in the long run, but right now there is none, because that's kind of like a dynamic question. You might be able to write your own custom dashboard. I think that might be interesting. If I had a workflow that had its own state, things a state machine, would that be opposed by a query? Yeah. So we have, for those interested in state machines, by the way, we had an example actually done by a student who did Temporal with XState, which is the kind of the state machine library. So Gregory, I encourage you to check this example out. I've pasted that in the chat as well. I think if I look at the workflow, it's got a bunch of signals that we can kind of take care of. So the state machine is kind of contained within the workflow. There we go. Here. So yeah, this is local state, and it's got all that state machine stuff. Temporal handles all that local state for you, and then it's interpreting it, interpreting every incoming query and signal via that state machine. It's a really nice implementation, and it's a fully working example. So I'm really happy that someone actually tried to do that, because then otherwise I wouldn't have to do it. Okay, let's actually go into a practical example. So I'm going to skip I'm going to skip ahead a little bit and actually talk about the Fullstack Next.js app, and then we'll close up with a discussion of workers and task queues, because I think the interest is kind of there now, and I'm feeling it a little bit. All right, so we're kind of done with this because I already canceled that workflow. I'm killing this, and we're going to go ahead and close out of this as well. All right, let's switch to the Next.js example. I hope I can do this right. cd Next.js, cd cd Next.js. So we have one pre-made here, and I'm just going to get that running. I think I can just run npm install. All right, so let me orientate you to the Next.js code base. Again, all samples are in one folder, so you can study that code. And hopefully it's well documented enough in the READMEs. Please let me know if they're not. Okay, so let me orientate you to this code. There's two sides. If you're familiar with Next.js, there's the server-side rendering page, which is kind of like this is like the landing page. This is the front end. And then there's the back end side, which is the API routes. And these are all serverless functions by default for Next.js. And here are all the clients that I've made for myself that kick off a purchase, or handle a query, or cancel a purchase, whatever. Okay, and then there's the temporal side, which is a folder. So this is kind of like a monorepo approach. So I put all the temporal related stuff inside of this folder, except for the client, and I put the workflows inside of here as well. All right, so go ahead and handle this. I'm just kind of cleaning up the comments that we use for our documentation. Okay, and then I think if I run npm run dev, it should work. Let me just read my own README. Yeah, npm run dev. Okay. npm run dev. All right. So we're building the Next.js site, plus we're kicking off Temporal. And we have a little site here. So this is kind of what we're trying to do. And hopefully, Eric, this answers your question in a really practical use case. So imagine a one-click demo where I'm clicking to buy, and that purchase goes through unless I cancel it within a certain set timer, right? So this basically models that question of like, did I mess it up? Okay, I think I may have messed up that UI a little bit, but essentially, like, this is front end code. It's not relevant to the back end. But essentially, I may want to click to cancel during that purchase, and I click to cancel, right? So this is a very important thing. That is very common with anything like racing conditions or anything like that. Let me see if I can rearrange this. There we go. Let's see this in Temporal Server. So here are the one-click purchases that I did. And I actually sent in that signal Where is the signal received? Workflow execution signal. Okay. All right. Let me show you the code where all this happened, so you can actually get a sense of what I'm talking about. All right. So here's the one-click buy code, where, for example, I'm kicking off that one-click buy whenever I click that buy button, and it stores the state of that item to buy. It sets the state to purchase pending. It sets up that query and signal handlers, so that I have a signal for handling canceling purchases, and I have a query for exposing that query state whenever I need to load it. And then I have a condition API call where I say await workflow condition until purchase state equals canceled, so that human signal has come in to cancel it, or 5 seconds has elapsed. If 5 seconds has elapsed, then a purchase is confirmed. So this condition API returns false. And if that cancel signal has come in, then this evaluates to true. Therefore, the whole thing evaluates to true. Therefore, I go ahead and call the cancel purchase activity. So this is a nice composition of like everything that we've been talking about so far in terms of signal, in terms of queries, in terms of timers. And hopefully that is a nice design pattern for you to model this asynchronous stuff. On the client side, so this is the workflow. On the client side, that's each client is established inside of this API route in Next.js. Everything starts off with the start by. So here I'm starting a purchase. I'm starting off that workflow whenever I click a buy button, and I'm saying like, you know, kick off this workflow with this transaction ID and this item ID. That's going to be processed by the workflow. And then when I get a cancel instruction, for example, I will get I'll get the handle again to the same ID, and then I'll signal that I'm canceling that purchase. And this signal is received over on the workflow side by the signal handler over here. And it says, I received that and I'm going to cancel it. This only has one use. So even though I pass an argument here, I actually don't need it because I don't have any other state to set anyway. So hopefully this actually helps you understand how signals and queries and condition API works in practice, because I think this is a super common design pattern that you may want to use for any number of things. And having the timeout there and having it evaluate to true and false makes for a very nice design pattern. Eric, did I answer your question well? Feel free to come on and just ask your question. You don't have to type it out as well. I assume that is okay. Yes, Eric says yes. Okay, great. So that is temporal within a Next.js context. I mean, there's all sorts of things I want to share with you, which is so cool about this system. I'll give you one example. So anyone familiar with React will observe that these kind of look like hooks. There's no state hook, but these are all sort of handler hooks. And that's kind of on purpose. So you can actually say something like define like sets of queries and signals and queries at the same time. So let's say something like function use state name. Let's just call this name. And I can define that name down in here. Let's see, let's just define the signal and query. See, signal. So this is I'm writing a generically usable function here. Sorry. Let's see, name. I can even do some type magic. Let's say type as any. And then return signal and query, something like that. And then I can also maybe set the handler inside of this as well. So I can set handler here, and then signal some local state. That state equals to null as null t, whatever. And then, so if that signal is receiving something, so like new state, I can set the state equals to new state. And why is this void? Okay. I'm not sure if I. And then I can set the query here. So I'm basically setting like a reusable function, and it's sort of composable by you. And the vision is that you would be able to, I don't know, to write whatever sort of custom hooks that you want, essentially. Maybe I'll call something like get state, right? Function get state equals to whatever, and then I'll return state. Right. So I've now defined a reusable use state hook, so I can sort of eliminate a bunch of this stuff. Rajat, you sound like you might have a question coming.
Oh, no, sorry.
Okay, no worries. Yeah, so I just want to show you, like, it is intentionally a very flexible system because it's meant to enable you all the powers of code that you might be used to in that sense. So say get state, right? Just get state. Whatever. Hopefully that shows you, like, it is a flexible code system where all of these workflow APIs are essentially composable hooks that you can use to modify in whatever way that you wish, and you can sort of regard workflows as React components almost, and they're as composable as that by design. Okay. I think we may have covered almost all the APIs. There are a bunch more workflow APIs. The high level I've kind of identified for you in the workflows doc, so you can actually go ahead and check out the table. So we covered activities, signals and queries, sleep, and condition. You can also kick off child workflows, and you can spawn a bunch of child workflows and control them from the parents. And they can also be canceled when the parents is canceled. You can continuous new for infinite workflows. You can patch them. You can create UUIDs internally, as well as do a bunch of like internal reflection, logging, and very fine-grained cancellation manipulation as well. So there's a bunch here. There's also like sort of cron activities that you can set from the clients, cron workflows. So I do want to mention that. But we don't have time to get into that, unfortunately. So I'll just kind of leave that there for workflow APIs. And then the final piece is on workers and task queues. So let's get into this. So just a reminder on how these things communicate. There's the client that talks to the cluster calls the worker that hosts workflows and activities. How each of these are basically calling each other is basically what we call through task queues. And that's kind of how the workers kind of communicate with the server, and the client also communicates with the server. So they have to be kind of matched. Otherwise, they're not even going to agree on each other. So let's actually go ahead and see if I have one lying around here. So you can look up the task queues in the UI here. So here I have a task queue called e-commerce one click. And if I click into there, I can see that I have one poller called this machine name, whatever that is. So that is set from the worker side, where we have the task queue of e-commerce one click, and it's called from the client side, where we also have the task queue of e-commerce one click. So this is why it's a required argument that we want to make sure that you set all these task queues correctly. If you typo them, they're not going to match, and your work is not going to proceed. But also the other interesting thing about task queues is that they're very lightweight, in a sense that you can design one task queue per machine, or just like any task queue for any number of dynamic reasons that you wish. So I think you can get really fancy with some ideas for stuff. So for example, one of the ways in which you can apply this, which is very common, is let's say you're building a CI/CD system and you need all the activities to be guaranteed to execute on the same machine in sequence. So for example, something about the modular approach in this system is that one activity can execute on one machine, and everything's by default assumed to be fungible, right? Like you can execute activity on one machine and then it goes back to the cluster and it has to execute the next activity. Probably it's going to send it back to the same machine, but you're not guaranteed that. So the way to guarantee it is to essentially say, all right, I'm going to create a custom task queue, which I call a unique worker task queue, and just for this machine. So all these subsequent activities are only done on this one machine. So we call that the sticky activities pattern. It's actually something that was also documented by Netflix when they do some of their production debugging with Temporal, and you can check that out in their talk. I think it's temporal.io/Netflix is the short URL. So if you're interested in the Netflix story of especially that sticky activity task queue thing, go check that out. There's also a fun pattern inside of the worker to do with shared dependencies. And this is not fun so much as required. Like it's almost required knowledge because everyone eventually starts to have shared dependencies of resources that they need to share. And it's whether it's a database connection or it's like some shared API clients that they need to put into all their activities. Basically, you create a factory functioning activities and you initialize it inside of the worker. So those are worker patterns that I can get into in support, and we also describe in the docs. I just want to make sure that you know it exists. It's not like we haven't thought about it. Okay. So we talked about the Next.js app, and I think now we're just coming into conclusions. I'm going to talk about next steps, and then I'm going to pause for questions. So where do you go after this? We've basically covered the feature tour of the core APIs of Temporal, right? Like now you know what a client is, how to write a worker, how to write activities, what the debugging process is like, some intuition as to which part of the system goes where. I think it's up to you now to think about your use case. And by the way, we have a bunch of use cases kind of spec'd out at temporal.io/use cases. Think about your use cases, think about your the case studies that we have, and really think about, how does that solve a problem inside of your company? It's a very general purpose system, which makes it very hard for people like me and Tiho because we don't often know sometimes exactly what you're thinking about using us for. But we do want to help you with your use cases because we think it's just a fantastic abstraction to have. And then we also have a bunch of other docs that I haven't covered here on security, testing, migrating, logging, all the important stuff, as well as joining our Slack, YouTube meetups. We do meetups every month where it's sort of Temporal users and like new updates on Temporal, and hopefully product launches as well increasingly. Also, Temporal server is the part that we do host for you. All this stuff is completely self-hosted, or I don't know, it's for you to run. We don't have any opinion about that. But either you have to run Temporal Cloud yourself, Temporal Cluster yourself, or we can run it for you. We're happy to chat. Just go to temporal.io/cloud if you want to indicate some interest in Temporal Cloud, because it's not generally available yet. All right, I'm going to pause for questions there. Feel free to unmute yourself, and I have some finishing slides if no one has questions. But I'm going to pause for questions. Any questions?
Yeah, I got a question, Sean. I saw somewhere that there's a notion of archiving, I guess past executions. Can you tell me when you would need to use that?
Yes, we don't recommend using it. So the archiving is an experimental feature, basically from the Cadence days. We are not sure how we're going to support it in the Temporal iteration, even today. But there's a workflow retention limit. So let me show on screen again. How long do you think these should stick around, right? This is already completed, like, how many of these do you want sticking around? And on the server, actually, we can configure that anywhere between 7 days and 30 days. But it is a relatively short thing because we do design Temporal to be a fairly high throughput system. So we can't keep everything around forever, right? So there's a sense of, or there's a notion of, I forget what we call it actually, persistence limit history or something like that, duration. Tiho, what do we call it?
Retention period.
Retention period. Thank you. I was blanking on that name. Yeah. So we set our retention period for Temporal Cloud is between 7 and 30 days. Beyond 30 days, the judgment is that you'll probably not need it anymore because everything ran successfully or unsuccessfully, and you already resolved it. But some people have compliance use cases. You need to keep things around for 7 years. And so we had archivals for dumping it out to an S3 bucket, essentially. We have that there. We do not support it from Temporal Cloud, but if you self-host it, some of our users do use that. We just don't bless it as a fully supported feature because we're not too happy with we want to iterate on the implementation as well. So that's the status of it as it is today. It's one of the more experimental parts of Temporal. Great, thanks for the question, Gregory. Always like having different voices, and I think you've had amazing questions so far. So thank you for sticking around for so long. Jay Garcia questions has, with workflow deterministic limits on node built-ins, how do you handle environment variables? With dependency injection, like we talked about. So the workers are not subject to those limits. So you can inject a DB connection pool, or you can inject environment variables inside of your workers, and your activities and workflows can sort of benefit from that accordingly. Actually, sorry, your activities can benefit from that. Workflows cannot. Yeah, so that's the status of that as it is today. Okay. Yes, Raul says, what about sessions versus the queues you just mentioned? Yes. Okay, so the people who are more familiar with other SDKs in Temporal may be familiar with the sessions API that is in, for example, Go. We're working on it. It's one of the things that we want to work on before we go generally available. So yes, this will become a native pattern. And yes, this is kind of like a hacky workaround, but I just think it's very cool because it shows a very deep, very clear understanding of what task queues and workers do for you. And because it's intentionally dynamic like that, you can make some really useful use cases, and if you're creative enough. Yes, but we'll bake this in by default as the sessions feature by the time we go GA for TypeScript. Okay. Pranav, how does self-hosted Temporal handle multi-tenancy with regards to multiple teams, leveraging it as a common infrastructure within an engineering org? Seems like all the names and symbols are global. Thank you, Pranav. That's a very good observation. The answer is namespaces. So yeah, all workflows, activities, whatever are unique as namespaces, and you just define different namespaces if you want isolation between them. All right, perfect. All right, we've hit 2 hours. That was amazing. I actually did not expect to end on time because we did run over the last couple times. Thank you to everyone who showed up, and you're totally welcome to join the Slack. Temporal.io/Slack is where we'll hang out and do support and all that good stuff. And you can come talk with us on the TypeScript SDK, sign up on our mailing list, and otherwise shout us out because I think we all need your feedback to make this the best SDK that we can possibly make it. So really appreciate you guys coming. I think the system will be sending you like a little review and feedback form. Please let us know how we can improve this session. We do this only for you. So thank you for coming. I'm going to stick around to answer any last minute questions, but otherwise you're welcome to peace. Thank you so much for coming, everyone.
Yeah.
Greg, Gregory, do you have any questions?
No,
thanks, Alex.
The same. Thanks.
Thanks, Brad. I love, I just love sharing this. So thank you for taking time out of your day. I know it's like a big ask, but people do. And then like hundreds of people watch our sessions asynchronously, which is pretty fun. Tiho, any thoughts? Any postmortems?
I think you did great. I learned some stuff about TypeScript too. I mean, I'm used to working on the SDKs where you have so much worry about determinism and what code you put and how you blah blah blah, sync async lists. I mean, but TypeScript makes this a lot easier, I think now.
I think so too. So I think what's his face? Samar always talks about how this is like better developer experience. Like I kind of take this for granted because I did some Go and then I went straight into TypeScript, right? So I haven't run into the non-determinism errors that some people get into in production. So I always wanted to do like a Halloween like horror story thing where we show off like, you know, what can go wrong. But I mean, even I shot myself in the foot with the await syntax. So I feel like we probably could use a linter and probably could improve on that kind of thing. Okay, I have a couple questions here. Jacob says, does the TypeScript SDK support running business logic after workflow execution timeouts, similar to cancellation? After a workflow execution timeout? I guess.
Does it support Saga?
Why would it not?
Yeah, TypeScript.
Yeah, just I haven't like modeled it out, but why would it not? It should be generally capable of that. What is workflow execution?
The reason I'm asking is because in the Go SDK we have run into like there is a timeout error that is defined in the SDK for that you can get off of the context.error API. But it seems like workflows act like behave like they've been terminated instead of ever being able to see that error in our actual workflow code in a cleanup function. Just wondering if that's actually a temporal server thing or part of the SDK.
Can you show me the exact like context.error thing that you're talking about? Because I feel like I'm just I'm not exactly sure where to go with this. I have some ideas for how to answer you, but can you show me the context.error thing?
Yeah, and I can take this into Slack too if that's easier.
Okay,
but I'll pull it up and go doc really quick.
Yeah, pull it up. I mean, we're in after hours time anyway. So I'm happy to explore this with you. My default answer is I want to say yes, because we did spend a lot of time on the error stuff, but I just want to make sure that I fully understand what you're trying to do. And handling workflow execution errors is just not something that workflow execution timeouts is not something that I've personally done. So I need to be careful around what I say here. Brad says, trunk.io simplifies checking and testing your code. Some kind of linting thing. That's a lot of linters. What is this? Brad, what you want to explain this? Have you tried it out? Wow. I mean, it is an impressive landing page. And it does track lint issues over time. That's pretty cool. Huh. Okay. All right. Jacob has come back with a link.
Yeah, that's not the one I was looking for, but so actually maybe that this does perhaps explain my confusion. I think you can get the timeout error when you're executing an activity and act on that, but maybe not when the workflow itself is timed out.
I see. I feel like, okay, so if you just look at our errors, I'm pretty sure we've handled that sort of thing. Yeah, this timeout failures include workflow timeouts. So what I would do here is kind of something like this, right? Let's say I'm in a client and I've done client.execute. I'm just going to switch over to the hello world example. Let's say I'm in a client and I've done client.execute. Would this work? Like try and then catch error, and then if error instance of timeout. Handle. Something like that. like you should be able to tell what kind of timeout failure like if it reaches here, it would be a workflow timeout failure, you know.
Sorry. It's okay.
Oh no, your dog.
Yeah. So the timeout I'm talking about handling is actually in the workflow code. So
In
say
the
you
workflow.
have like a long running workflow, like the subscription example.
Okay.
Maybe you say like, okay, a customer signs up and then you send them an email and you're waiting on them to click the activation link in their email to start billing them forever.
Yeah.
So if you have a timeout for like a child workflow for sending the email, you might want to like perform some cleanup after that to say like, I don't know, remove a record from a database. So would you need to like have a timer within the workflow code that is smaller than the workflow execution timeout? Or can you register, like defer some cleanup logic that's handled when the workflow itself times out?
Got it. So this is specifically for child workflows.
Any workflow.
Because the default workflow execution timeout is 10 years, right? Like that's not the kind of timeout that we're talking about.
Right, like I guess I'm talking about business level timeouts.
This is the workflow execution timeout.
Workflow execution timeouts as a business level timeout, and like still have deferred cleanup logic that you run when the workflow does timeout.
You could, but you'd have to do something funky like. I wouldn't recommend it. I basically would just use like a real timer. And with the timeouts, like that's why we have await, workflow.condition. I can spell. Like there's a timeout clause here, right?
Right.
Is this enough for you or?
Yeah, no, that makes sense. And was my current understanding. I just wanted to double check that it wasn't just like a Go SDK thing.
No, yeah, I wouldn't recommend mixing those business level and sort of activity level timeouts.
Yeah, that is kind of a point of confusion sometimes for our users. Oh, I'm so sorry. It kind of looks like you could use that as a business level timeout. You don't know exactly what the timeout or just a timeout would otherwise, and like setting the timeout on a Go context for an arbitrary API request.
Gotcha. Okay, your internet's kind of breaking up there, but I appreciate the question, and we can also carry on in Slack.
Thanks. Sorry about that.
Yeah, no worries. Yeah, I realized I forgot to like give the final few slides, but also I feel like I already kind of screwed the pooch there. Yeah, I think basically I'm just gonna fast forward to the end for the purposes of recording and say that this has been the workshop. I think we're gonna have this on YouTube, so you can subscribe on there. We have a mailing list as well as a Slack for people to continue the conversation. So that's it. I'm gonna stop the recording and thank everyone for coming.